This is going to be a short video introducing student T's distribution for BA 254. You can find all kinds of information on student T's distribution by looking online or even YouTube. I'm sure you can find an absolute ton of different videos and resources that explain student T's distribution. But I'm going to do just a really quick introduction to student T's distribution. There's also a really nice section in Dr. Alexander Holmes's OER textbook related to this development, a real short amount of history. But this is going to be a quick video just primarily for my BA 254 students to talk about what is a student T's distribution as a point of introduction. So I kind of find it funny when I listen to statisticians get together and they kind of argue about kind of the root of all evil that is a Z distribution, right? They have some really strong opinions. It's kind of cute, like Bunny in the Woods, you know, to listen to them argue about the limitations of a Z distribution. And so they'll get into that, and then many will extol the virtues of a T distribution. And it's an interesting conversation to a point, and then I kind of ended with, as some of my students know, I'll say something like, yeah, these are clearly some individuals that haven't really had a real job, because we can get into all kinds of arguments about the differences between a T distribution and a Z distribution, but understand they're very, very similar. All right, T distribution is much like a Z distribution in that it's symmetrical. That's a hugely important part in dealing with a T distribution, okay? It's symmetrical. Again, it's standing in for the probabilities, the total area of something happening. The total area is 1. It kind of is centered at 0, okay? So it's kind of like our standard normal values. The whole, all of the distributions are centered around 0. The big difference is the T distribution is literally just wider and flatter, right? It just literally has some different characteristics. Now, there is a family of different T distributions that are based on the degrees of freedom. So what we find is then this T distribution will have a certain degrees of freedom, and this T distribution right here, will have a different degrees of freedom. For us here at this point in the semester, our degrees of freedom are going to be n-1, n-1. And I'm not going to get into the detail of that other than we're going to literally go in and say we're going to reduce our sample size by 1, and that's going to give us these degrees of freedom at any individual corresponding T distribution. What happens as these degrees of freedom go up, in fact, as they get infinitely large, what you see is that the T distribution becomes a Z distribution. The Z distribution is, in fact, then the limiting distribution of the T distribution. Another couple of things to point out, too, that we have similarity between the Z and the T. These T distributions are also continuous. They're continuous probability distributions. They're also asymptotic, right? We have kind of some crazy relationships going on down here where these curves approach this axis. So there's a huge amount of similarity there. For us, again, our guideline will remain for BA 254 that if our sample size is less than 30, we're going to use a T distribution. If our sample size is greater than or equal to 30, we're going to use a Z distribution. We can also use these Z distributions when this population standard deviation is a known value, right? That one kind of supersedes our sample size. But this, just to be clear and objective, is what's going to enable us to, or it's going to tell us which one of these distributions to use. That's a really short, quick introduction on T distributions. We will continue to use them. In fact, the next video we will look at will be using a T distribution to develop a confidence interval where the sample size, where the population standard deviation is unknown and the sample size is low.